Hello guys, let's have a look at the next question. State what is meant by mass of a body. So in lower classes, we were asked or we were made to understand that mass is anything that occupies space. But as we go to higher standards and we learn the concept of a gravitational force, we understand to define mass of a body in terms of gravitational force. So here's the definition. We understand that a mass of a body is that property which helps it exert and experience a gravitational attractive force. I'll repeat myself. Mass is that property of a body which helps the body exert and experience a gravitational attractive force. We don't have to mention attractive because gravitational is by definition an attractive force always. Moving on to part B. Two blocks travel directly towards each other along a horizontal frictionless surface. The blocks collide as illustrated. So here we have a diagram where we see the collision of two blocks and we see their corresponding masses and velocities before and after the collision. There is an identification to be made here. Since velocity is a vector directed towards the left is taken to be negative, while a vector directed to the right is taken as positive. Moving ahead, they have given that block A has a mass of 3m, while block B has a mass m. Before the collision, block A moves to the right with a speed of 0.4 meter per second, and block B moves to the left with a speed of 0.25 meter per second. After the collision, block A moves to the right with a new speed of 0.2 meter per second, while block B moves to the right with a speed of v. Use Newton's third law to explain why during the collision, the change in momentum in block A is equal to and opposite to the change in momentum in block B. Let's understand Newton's third law first before we explain this. Newton's third law as a statement says exactly this. Apologies. Newton's third law says that every action has an equal and opposite reaction. Let's apply this to an example question. Let's take the collision of two masses. Let's take the same masses given in question. I'll assume the first mass as block A, the second one as block B. When the two masses collide, we know that a block A applies a force on block B determined by FAB. And from Newton's law, it is evident that block B applies an equal force, although in the opposite direction, called FBA. Force is a vector, so I'm indicating as such. Now, moving ahead, we understand that the force applied by A or force applied in general follows the formula F is equal to delta P by delta T. Which is another way of saying that force is rate of change of momentum. And since here force is applied by the block A, so FAB represents the rate of change of momentum for A, and FBA represents the rate of change of momentum for B. Substituting, we understand that the formulas can be further written as FAB is the change in momentum in A, the change in momentum P for body A, divided by the time t equal to the change in momentum for body B for the same change in time t. If time is erased, we understand that the change in momentum in A is equal to the negative of change in momentum is B. The negative sign further indicates that the two momenta are opposite directions. And since momentum is a vector, yes, direction does matter. This is further proof of Newton's third law being applied to this specific question. Now further, we are asked to determine the speed v. For this, we can use this equation or an abridged version of the same called the equation of conservation of momentum. So conservation of momentum is as follows. It says that if two bodies A and B or M1 and M2 are involved in a collision where their initial velocities U1 and U2 are changed to final velocities V1 and V2, we understand that the total momentum before collision is equivalent to total momentum after collision. So M1 U1 plus M2 U2 should be equal to M1 V1 plus M2 V2. Substituting for the above specific condition, M1 is 3 times capital M, whereas U1 is plus 0.4. M2 is just capital M, and U2 is minus 0.25 owing to its direction. This is equal to M1 again, which doesn't change. It stays as 3M. V1 now changes, however, to plus 0.2 plus M2, which again stays the same as capital M, but V2 is an unknown value. The V2 velocity is what we are determined to find. And substituting and cancelling M on either side, we end up with a value for V as 0.35 meter per second or meter second to the power of -1. Moving on, calculate for the blocks the relative speed of approach. The relative speed of approach is calculated simply by adding the two velocities 0.4 or subtracting the two velocities, in fact, 0.4 negative of negative 0.25. And when I do this, I end up with the relative speed of approach as 0.65 meter per second. The reason I'm subtracting is because they're both traveling in the opposite direction. Now moving on to the next part. The relative speed of separation, same logic. We follow the same logic here. We do 0.35 minus 0.2, ending up with an answer of 0.15 meter per second. But the values are written here. No need to write meter per second. Moving on, use your answers in B part 3 to state and explain whether the collision is elastic or inelastic. We notice that the relative speed of approach is 0.65 meter per second, while the relative speed of separation is 0.15 meter per second. And since the two values are not equal to each other, or in fact, the separation is lesser than that of approach, we conclude that the collision is inelastic, which is another way of saying that kinetic energy is not conserved during this collision. Thank you.